So welcome everybody to this latest video on 162 Maths, and in this video we'll be going over a quick topic test with a collection of GCSE exam style questions on introduction to area and perimeter at foundation level. Now a copy of the questions for you to have an attempt at before watching through this video is available for you to download by clicking on the link in the description, which I strongly recommend you do to see how much understanding you have on this topic. Now, before we get started, it's worth mentioning that there is no indication about whether these questions relate to a calculator or a non-calculator paper. So what we'll do is we'll just assume that they are non-calculator. Then obviously, if they turn out to be a calculator paper, then we've got the bonus of using a calculator. So let's get started on question 1. So question 1 says this rectangle is 7 centimeters long by 5 centimeters wide, and the first part for 1A is asking us to calculate the perimeter of the rectangle. Now again, what you want to do whenever you see the word perimeter is just remind yourself what is the perimeter. Now the perimeter is basically the shortest distance around a shape, which in theory is the sum of all the sides you can see. So by filling in and missing the missing lengths, we can see that for the perimeter we just need to add 7 plus 5 plus 7 plus 5. And what I like to do is either, if it's a compound shape, is just pick a point and then just go either in a clockwise direction or an anti-clockwise direction till you return to the point, and then adding all of those numbers up we get an answer of 24 centimeters. Now for the area of a rectangle, that's just going to be the length times the width. So that's going to be 7 times 5, which is 35. And we don't need to worry about the units because that's been given to us. For question 2, it says work out the perimeter of this triangle, simplify your answer. So for this, all we need to do is again add up each of the sides. So we've got 2a plus 2a plus 1a, which gives us 5a. Then moving on to question 3a, it says find the formula for the area of each of these shapes. Well, this shape here is a triangle, and so you should know that the area is going to be either base times height divided by 2, or you could write it as a half BH. For question 3, here we've got a rhombus, and with the rhombus, the formula is basically exactly the same as the triangle. So here we've got the general length, and here we've got the height. And the general formula is a half L times H divided by 2, or half LH. Now in this case, L is 2A and H is 2B. So if I replace these two values into either of those two formulas, I'm going to get 4AB divided by 2, and 4 cancels with the 2 to then leave me with 2. So the final answer is going to be 2AB. Then moving on to question 3c. So here we've got 4 semicircles with a diameter of D, and we've got a square in the middle. Now what's worth mentioning on this is when you've got a compound shape is to basically label each of the different shapes. Now if a shape is the same, you can just label that as the same letter. In fairness, it's probably more efficient to do it that way. And so here we've got 4 semicircles and we've got a square. Now for the square, we know that that's going to be D squared. And for the semicircle, well here, what we need to recognize is that the radius is a half D, or D divided by 2, but I'm going to leave it as a half D. Now for the area of a semicircle, that's pi times the radius squared divided by 2. Now in this case the radius is a half D, so if I substitute that I get pi times a half D squared divided by 2. Now I'm actually going to need 4 of those, so if I multiply this by 4, then what happens is that 2 cancels with the 4 to leave me with 2. So in theory what I've got is I've got pi times a half D squared multiplied by 2. Then from this, what I've then got is pi times, now with the square, if I square the fraction and square the letter, well, looking at the fraction, 1 squared is 1, 2 squared is 4, and D squared is D squared. Multiply that by 2, and then what that then becomes is, if I just move that over here, I've got pi times, now 2 quarters make a half, so that's going to be a half D squared. So this is all of the 4a's, And so what I need to do is add that to b, which is d squared. Now recognize that here we are multiplying, so if I just neaten that all up, I've got d squared plus, and it's going to be a half pi d squared. Now you might think to yourself, well, can I join those two things together? In theory you can, but I probably would opt for leaving my answer as this, or you could simply factorize it with respect to d squared, so you've got 1 plus a half pi. Any of those two would be absolutely fine as a correct answer. Then moving on to our last question, question 4, it says the trapezium and the square have the same areas, and the question says what is the perimeter of the square? Well, the first thing we need to do is work out the area of the trapezium. Now the area of a trapezium, the formula is a plus b multiplied by h divided by 2, or you could have the formula as a half h and then multiplied by a plus b. Now a and b are always the two parallel sides, and obviously h is our height. So to work out the area of the trapezium, that's going to be 2 plus 6 multiplied by 9, all divided by 2. So 2 plus 6 is 8, so that's 8 times 9 divided by 2, which is 72 divided by 2, which gives me an answer of 36 centimeters squared. So that means that the area of the square equals 36 centimeters squared. Now if I just call the length of the one side of the square as x, that means x squared equals 36. So x equals the square root of 36. So x equals 6. I don't know why I've written 3, so let me just get rid of that. And 6. Now the question is not asked for the side of the square, it's actually asked for the perimeter. So if I just label the sides of the square as 6, 6 and 6, so then the perimeter is going to be 6 plus 6 plus 6 plus 6, which gives me a final answer of 24.